I'm Anil Kumar, sharing with you some ideas of understanding functions. We are going to discuss characteristics of the given relation. The question here is determine whether each relation is a function or not and list their characteristics including domain range and behavior, increasing, decreasing interval, symmetry, etc. So you see C is x equals to y square. So we actually began with a different kind of equation where we had 6 parts, and this is the offshoot. So we are discussing in details this particular equation x equals to y square in the video. You can follow the link to see rest of the examples. So now let's answer the very first question, which is determine whether each relation is a function or not. The trick is, in the given equation, look for y square. If you see y square, you can straight away write not a function. Very clear. Now I'll actually prove you how, correct? How it is not a function, right? So easy way is take few values of y and get some values of x. So if I take y as 1, right? So what happens? Let us say I'm taking y for a purpose since x is written on the left side. So if I take y equals to 1, I get x equals to 1, and if I take y equals to minus 1, I get x equals to again 1. That simply means that for x equals to 1, we have two y values. We have y equals to plus 1 and we have y equals to minus 1. You agree with me, right? Since we could find a point where x is associated with more than 1, the relation is not a function, period. So that is how you can actually show whether the given equation is a function or not. Now here is an alternate method. Alternate method is to isolate y, right? So let's do that. So from here we can rearrange. So what we get is y equals to square root of x. Whenever you do square root, you have to consider both plus and minus signs. Okay, that is why you get two values. That is how it is. Now since y is plus and minus square root of x, clearly x values greater than 0 will have two y values. So they are not uniquely associated. So this relation is not a function, correct? So that is algebraic proof. Third part is we could actually sketch it. So let's also sketch this particular. So I'll squeeze in a sketch here. Leave the space for characteristics. Okay. So when you do y equals to plus square root x, you get a function which will look like this. And when you do minus square root of x, you get this part, the lower half. And clearly, if I draw a vertical line, it intersects at 2 points, and therefore it is not a function, correct? So either way, you can prove that this is not a function. So this is not a function. Is it okay? Now let's talk about the characteristics. From the given graph, it is very easy to write down the characteristics. Let's begin with domain. So domain here is x belongs to real numbers where x is greater than equal to 0. On the right side, you see this is x-axis, this is y-axis, that's the origin, greater than equal to 0. Range. As far as range is concerned, y belongs to real numbers. There is no restriction. It could go to negative infinity and to positive infinity. End behavior. So end behavior is what happens. End behavior is what happens to the graph as x approaches large negative and positive value. Since the domain is to the right side of origin, we can only approach positive infinity. In that case, y approaches both ways, right? So negative and positive infinity, right? So in this particular case, it is not defined. Well, that makes sense because this is not actually a function, it is a relation. So it is not defined. We don't know whether we're talking about the upper half or the lower half of the graph. So that is very interesting example. Okay, so that is the end behavior. And now, um, as far as the symmetry is concerned, we know x-axis is the line of symmetry for this particular graph. So that is not a particular symmetry which we normally talk about, but we can say x-axis is line of symmetry. It is neither odd or even. We are not talking about odd or even symmetry, since remember we have a relation which is not a function. Okay, so you'll see some discrepancies in the characteristics when we compare this relation with normal functions, and that is how you could actually show them, correct? So these are a few characteristics. You could also say that this particular relation, the graph of it, is in quadrant 1 and in quadrant 4 only, right? So that could be also a characteristic for this function. So likewise, you can have so many characteristics. I hope that really helps. Thank you and all the best.